In this session, we'll take a look at the sum and difference formulas. And the sum and difference formulas are used to find the exact values of trig functions. If we take a look at this first set, we have the sum of cosine. The second formula is the difference of cosine. And notice the formulas are as follows. We then have the sum of sine, the difference of sine, and also the sum and difference of tangent. And now we'll simply use these formulas to find the exact values of trig functions. In addition to the formula sheet, you will also need your unit circle, as we will be finding the cosine and sine values of angle measures. So let's take a look at some examples. In this example, we'll find the exact value for the sine of 15 degrees. If you look in your unit circle, you will notice that there is no 15-degree angle in the unit circle. So we'll use a combination that will give us 15. So I'm simply going to rewrite the sine of 15 degrees as the sine of 45 degrees minus 30 degrees, as 45 minus 30 gives us 15. If you take a look closely at this expression, notice that this is a difference of sine. So on your formula sheet, if you locate the difference of sine formula, notice that the difference of sine formula states that it's the sine of A times the cosine of B minus the cosine of A times the sine of B. So I'll simply write that formula above my problem. So the sine of A minus B, that's equal to the sine of A times the cosine of B minus cosine A times the sine of B. So in this formula, I'll simply substitute A for 45 degrees and I'll substitute B for 30 degrees. So I'm going to write this out as the sine of A, which is 45 degrees, times the cosine of B, which is 30 degrees, minus the cosine of 45 degrees times the sine of 30 degrees. If you take a look at your unit circle, you can actually pull out the values. The sine of 45 degrees is the square root of 2 over 2. The cosine of 30 degrees is square root of 3 over 2 minus the cosine of 45 degrees, which is square root of 2 over 2, times the sine of 30 degrees, which is 1/2. Next, I'll multiply the two fractions, so I'll multiply the numerators and multiply the denominators. So I have the square root of 6 over 4 minus the square root of 2 over 4. I now want to subtract fractions. I have a common denominator, so I'm going to keep my common denominator and combine my numerators. So the exact value for the sine of 15 degrees is the square root of 6 minus the square root of 2, all divided by 4. Next, we'll find the exact value for the cosine of 5 pi divided by 12. The very first thing I'm going to do is convert 5 pi over 12 to a degree measure. You want to keep in mind that pi is equal to 180 degrees. So if we multiply 5 times 180 and divide that by 12, we see that 5 pi over 12 radians is actually a 75-degree angle. So I'll rewrite the cosine of 5 pi over 12 as the cosine of 75 degrees. If you look within your unit circle, you'll notice once again that there is no 75-degree angle, but we can use a combination of angles that will give us 75. So I'll rewrite the cosine of 75 degrees as the cosine of 45 degrees plus 30 degrees. And then when using these formulas, it does not matter if you use 30 first or 45 first. Whatever combination gives you the desired outcome. If you look closely at your expression, you'll notice that this is a sum of cosine. So if you take a look at your formula sheet, the sum of cosine is equal to cosine A times cosine B minus sine A times sine B. So I'll simply write this out as the cosine of A, which is 45, times the cosine of B, which is 30 degrees, minus the sine of A, which is 45 degrees, times the sine of B, which is 30 degrees. I'll next use the unit circle to pull out the values. The cosine of 45 degrees is square root of 2 over 2. The cosine of 30 degrees is square root of 3 over 2. The sine of 45 degrees is square root of 2 over 2. The sine of 30 degrees is 1/2. And now if we simplify, so we have the square root of 6 minus the square root of 2 all over 4. In this example, we'll find the exact value for 7 pi divided by 12. So once again, we'll convert 7 pi over 12 radians to a degree measure. Keep in mind that pi is equal to 180 degrees. So 7 times 180 divided by 12 gives us 105 degrees. So I'll rewrite the tangent of 7 pi over 12 as the tangent of 105 degrees. If you look in your unit circle, you'll notice once again that there is no 105 degree angle. So we'll use a combination of angles that gives us 105 degrees. So I'll simply rewrite the tangent of 105 degrees as the tangent of 60 degrees plus 45 degrees. And if you look closely at the expression, this is a sum of tangent formula. So if we look at the sum of tangent, it's tangent A plus tangent B over 1 minus tangent A times tangent B. So I'm going to write this out as the tangent of 60 degrees plus the tangent of 45 degrees divided by 1 minus the tangent of 60 degrees times the tangent of 45 degrees. I'll next pull out the values from our special angle chart. So the tangent of 60 degrees is square root of 3. The tangent of 45 degrees is 1 over 1 minus square root of 3 times 1, which is the square root of 3. The next thing I want to do is I want to rationalize the denominator. In order to rationalize the denominator, I must multiply the numerator and the denominator by the conjugate of the denominator. So we have the square root of 3 plus 1 over 1 minus the square root of 3. The conjugate of 1 minus the square root of 3 is 1 plus the square root of 3 over 1 plus the square root of 3. Next, I want to multiply the two fractions, so I'll basically multiply the tops and multiply the bottoms. When you multiply the square root of 3 plus 1 times 1 plus the square root of 3, you can either use the full method or you can use the sum of squares formula. So by using the sum of squares formula, it simply says that a plus b quantity square is equal to a squared plus 2ab plus b squared. So if I look at my sum of binomials, a is square root of 3 and b is 1. So in this formula I can treat a as the square root of 3. So if you were to square the square root of 3, we get 3 plus 2 times a times b. So 2 times the square root of 3 times 1 is 2 times the square root of 3. And if you square your last term, 1 squared gives us 1. Or you could FOIL that out, first, outer, inner, last. In the denominators, you can also FOIL out the denominators, but you should also recognize this as a sum and difference of squares. The sum and difference of squares formula states that a plus b times a minus b is a squared minus b squared. So if we look at our sum or difference, a is 1, so if I square 1, I get 1. Minus, because there is a minus in the formula, b is the square root of 3, so we're going to square the square root of 3, which gives us 3. And now if we simplify the numerator, 3 plus 1 is 4. And we have negative 2 in the denominator. In order to simplify, I'm going to treat the denominator as a denominator of every term in the numerator. So I'm going to write this out as 4 over negative 2 plus 2 square root of 3 over negative 2, which gives us negative 2 minus the square root of 3 as our exact value. In this example, we're asked to find the exact value for the sine of 40 times the cosine of 160 minus the cosine of 40 times the sine of 160. If we take a look at our sum and difference formulas, we want a formula that has a sine cosine minus a cosine sine pattern. And I found that in this difference of sine formula. You want to keep in mind these formulas, as well as any other formulas, can be worked in reverse. I'll simply write that formula in reverse above my problem. So we have the sine of A times the cosine of B minus the cosine of A times the sine of B, and that's equal to the sine of A minus B. So you can see in this formula that we're going to substitute A for 40 and B for 160. So we have the sine of 40 minus 160. 40 minus 160 is negative 120 degrees. You want to keep in mind that for negative angles we have 0, negative 90, negative 180, negative 270, and back around to negative 360. Negative 120 is an angle in the third quadrant. In order to use the unit circle to find the exact value for the sine of negative 120, I simply want to rewrite this as a positive angle between 0 and 360. So I'm going to add 360 to negative 120. Negative 120 plus 360 degrees is equal to a positive 240 degree angle. Therefore, negative 120 degrees and positive 240 degrees are coterminal angles. I can now look within the unit circle. I can find 240 degrees. The sine or the y value for 240 degrees is negative square root of 3 over 2. So we have our exact value as negative square root of 3 over 2.